I'm Jessica Walker, and this summer I did an REU, and I went to Worcester Polytechnic Institute in Massachusetts. The project that I was working on over the summer was the thermal stability of phosphoinositide domains. So this is the family of phosphoinositides, and the one that I worked with specifically was the PI45P2 phosphoinositide. And I worked with this because it has a negatively charged head group, and it can interact with positively charged amino acids along with multivalent cations like calcium, magnesium, stuff like that. The way that I was interpreting and finding data and analyzing this was through Worcester resonance energy transfer, shortened by FRET. And the things that we were really looking for FRET to work for my project was the overlap of the donor emission and the acceptor excitation peaks, and the donor acceptor molecules had to be close enough to each other, about 10 nanometers apart is the furthest they can be. And our hypothesis for the summer was that strong FRET would show that the donor intensity is low and the acceptor intensity is high, so which would be high temperatures, as you can see right here. So the domains are kind of broken apart, they're not together anymore. And then with weak FRET, it would be that the donor intensity is high and the acceptor intensity is low. So that'd be at low temperatures where the domains are still together, as you can see in this picture. For the vesicle compositions that I did this summer, it was varying percentages of phosphatidylcholine, or POPC, cholesterol, the PI45P2. The donor fluorophore that I used was top fluor PC, and the acceptor fluorophore that I used was WPI TMR PI45P2. And then this is what a LUV is, so a large unilamellar vesicle. It's about 190 nanometers in size, and vesicles, when you make them, they tend to come very packed together. So the way that I made these vesicles was to get that vesicle composition dried under compressed nitrogen, and then that was kept overnight at about 45 degrees Celsius under a vacuum in an oven. And then the next day I would take the vesicles out, add the solution to it, and the vesicles would be vortexed for about a minute and then incubated at 60 degrees Celsius so I did that 3 times. And then that was pushed through the extrusion kit that you can see at the bottom right here. And then after it was extruded, about a minimum of 31 times was about all it took, I would check that with a dynamic light scattering to make sure that I had one solid peak and there was only that vesicle in there, and that's what my extrusion gave me. And then after that, I brought that final concentration of my vesicle to 0.5 millimolar. And then this is the data that I got. So we did do varying percentages of cholesterol and found out that with 40% cholesterol at the acceptor peak, there wasn't really much of a change as you were changing temperature that you could see. There was a slight change, but the domains were too solidified to really show anything. But once you changed it to 30%, you saw a little bit more change at the acceptor peak, and that's what we really wanted it to show our data. And so I did 3 different compositions, and there were 2 FRET controls. So one with only the donor fluorophore, which is present right here. So that's just that donor peak right here at about 5-10 nanometers. And that's what it showed up for the top fluor. And then a FRET control with only the acceptor fluorophore present. And as you can see right here at about 570, 575, that's where the WPI TMR showed up on a fluorescence spectrometer. And then finally a FRET where both the donor and the acceptor fluorophore was present. And the concentration that I wound up using almost all summer was 50% POPC, 30% cholesterol, 20% PIP2, and 0.1% top floor with 0.3% WPI TMR. And as you can see right here, there is this change right here, and I took points right here of 575, which got me this graph to show that the temperature dependent melting and with this concentration. So at about 40 degrees, you can see that the domains started to melt, and then it started to plateau as you got to about 60 degrees Celsius. So in conclusion, I found the ideal fluorophore ratio to monitor domain melting over the summer and determined that the domain started to melt at around 40 degrees Celsius. And for future research that a grad student that I was working with is probably doing right now, is to compare the thermal stability of cholesterol-induced domains to calcium-induced PIP2 domains, and work with the thermal stabilities of phosphoinositol monophosphates and triphosphate. And then outside of the lab, we had a little fun, because with REU you have to add activities. So one group activity that we did two, was to go to Purgatory Chasm, which I couldn't find any pictures of. And so it was just about a 20-minute drive from the college, and it was kind of a hike. I didn't really like it because I don't like hiking, but it was fun to bond with the group, get to know some of the professors that went with us. And then another thing is that we did the Freedom Trail in Boston. We didn't walk all of it, but it was really cool to see a lot of the historical places. We went into a church that has been there for forever. We walked past a graveyard that actually has, I think, John Adams is buried there, so that was really, really cool to do. And then one of the things that we did as a group that outside of the professors, the professors didn't come with us, was we did escape rooms in Worcester. So that's what this picture is right there. And REUs are just a great opportunity for science students.